Well, thank you again for joining. My name is Anil Maheshwari. I live in the US and I'm delighted to have worked with McGraw-Hill and published a book on data analytics. And I wanted to talk to you this morning about a topic very uh, near to my heart. I love working with this topic, data. And so this is data science. So we'll talk a little bit about what is data science and what are some best practices. And so we'll talk a little bit about what are patterns. What is this data science all about? And as I see it, it's about discovering patterns. And you know what pattern is. So pattern is something that we can grasp something with. And patterns are helpful because it helps us understand the world in more parsimonious ways. And patterns are something that we intuitively find out that this will be good, this will be not so good, this will be easy, that will not be so easy. These are the three things we need to do in general to get a class going, and so on and so forth. So pattern recognition, pattern determination, that's some of the basic tools that we have in life to work with other people or for our own life. And then we'll talk a little bit about what's data and what's the data processing chain, how we go from data from sort of what is data to all the way is data production, mining, and consumption, and some of the data mining techniques. And in between, I'll share some best practices about working with data. For example, work small. Don't sort of start with huge data or don't start with too many components of a pattern. Try to get basic things understood and then refine your understanding as you go along. Okay. So if you have any questions, you can start typing in, and then I will try to keep reading them. And as time comes by, I will begin to include them in my presentation. So moving into the very first chart, business intelligence and data mining. So you heard of business intelligence, you heard of data mining. Business intelligence is the art and science of providing relevant information to businesses for decision making, and how you produce the right information and how do you present it to the right people. And data mining is about okay, let me address some of the questions also. So I'll get to how long I've been in data science. I've been working data science about explicitly in the last 5 years, working in data science. But I've been sort of doing data analytics for the last 20 odd years, 25 years. I've been doing data analytics for free for a long time for a lot of people, the dissertation data and other data sets, even before it was called data analytics. So a lot of statistics and other things to work with. Okay, I'm just looking at if anybody's having trouble. Can't see anything. Okay. What is the best way to begin the career in data science? Can you define data science very well to others? Data mining. Okay, so the questions are coming. So maybe data science is the art and science of working with data, particularly large sets of data, to get relevant decision-oriented information to the right people in real time. So for example, you're looking at working or let's say monitoring your websites. You're working with data coming in from social media. You're working with data coming from your operations, and having the right kind of decision-making information about whether your infrastructure is working all right, or whether your website is up, whether you're having an attack from some other malicious forces, hacking attacks. All these things you can monitor in real time from the data that's available to you. And then, so not only defensive insights, but certainly what are some of the patterns that are happening in the world out there, so we can find some new ideas to grow our business. Someone said I want to know about big data analysis. I'm just trying to see if I can see everybody's comments at the same time. Alrighty, let's see. Okay, So it says you've been doing research in data analytics, or you've been asking my research. Uh, I have been teaching data analytics a lot, some amount of research, but not necessarily a whole lot of publications in the data analytics. But certainly I've taught a lot and brought together a lot of information and data analytics together to be able to write it in an easy to understand way. Um, so as I was saying, this is what is big data, what is Hadoop. Okay, so big data and Hadoop. So let me just stay on with this thing. Otherwise, big data and big data Hadoop will begin to be a slightly tool-oriented discussion. But let me just stay with data analytics for a moment, and then we'll come to the tools when we come there. Is that okay? So as I say, if you look at the picture, business intelligence data mining, that okay. So Internet of Things is, so there is an element of business intelligence data mining, and there's an element of big data, that how you work with big data. You can do data mining and data analytics with small amount of data, or you can do with infinite, a million times that data. So once you work with very large data sets, it becomes data science, and or big data science, or big data analytics. And today I want to talk about more data analytics to give you a flavor for data analytics, what it is. And so somebody says, what is the difference between business analysis, data science, and big data? So okay, that's a good question. What's the require mathematics and statistics? How does data science connect to industries and any organization? What is IoT? All of these, okay, so let me step back for a moment. What are these terms? Big data, data science, data analytics, data mining, data visualization. So how do you get started? So I've done some other video earlier on what are career options in data science. But for now, let me just try to differentiate these terms, because these terms have been coming. What is data engineer? What is data quality? And so on and so forth. What is the option of pursuing master's data science? But let me step back and say, data science is the new name for the field. As the field matures, so it's gone beyond data mining, beyond data analytics, and has become data science. And as such, it has traveled into many departments. Today, data science resides in computer science, it resides in business department, it resides in statistics, and it can reside even in domain knowledge. It could be residing in medical domain also, to the extent you do medical data analytics. So it can apply to journalism, like this gentleman is writing here. So do you need to be good in mathematics? Yes and no. Yes and no. There are parts of data science which will require a lot of mathematics, the parts of data science which may not require a lot of mathematics. So applications of analytics in HR, application of analytics in manufacturing, everywhere. So data analytics is to get insights. For example, you can find out can I answer this question with Ravi Prasad about how does it apply? So let's take HR as a very good example. How do you make sure that people you hire stay long in the company? How do you predict who's likely to stay? Or how do you predict who's going to be productive? How do you predict that who will gel well with your other existing employees? So you do a lot of tests, and if you can develop a predictive model which says those who do this well on this aspects of the test, or this particular test is a good predictor of a person's success and joy and success in this company. So that would be one application there. So we're still talking a lot of opportunities, etc. So a lot of questions coming on opportunities. How do you develop predictive model? So all good questions. I think I'll address them as we go along. So weather forecasting, all that good stuff. So let me step back to this framework. So one of the things you need to understand is why data science. Not only this and that, but why do we even care? I was mentioning earlier business intelligence. So this is the idea of generating business, means a good, useful information for any decision maker in a weather business, or HR, or in any industry, healthcare industry, or any industry. What is data mining? Data mining is a fairly old concept now, if I may say, but at least few decades old, where you took data and sort of mined it for patterns. You look for some particular predictive models or explanatory models through regression, through other techniques to make some sense of data. So lesser coding. So I'm seeing a lot of questions coming in. That's great. So the important thing is to know that while data mining is a relatively technical task, like people are talking about mathematics and math is required here, statistics and that kind of technical artificial intelligence kind of techniques required, neural networks, etc., in data mining. Business intelligence is the art of understanding the business person's need or decision maker's needs, understanding what they want, how they want it, and then presenting the information, helping them understand this is what it is. Now, how do these things relate to each other? Business wants certain things. Data mining can take the data and bring of whatever patterns they want to take out, and it depends whether data has the pattern or data just says no, it's all random stuff. So you don't know when you're mining data, you don't know what you'll find out. So that's what keeps it interesting and suspenseful. The data is the master. At the same time, you need to explain the information as patterns to the decision maker in a way that they can understand. If you give out very long, complicated equations, they won't understand and they won't use it, in which case all your effort is wasted. And without data and data mining, then you can't give something nice to the business. So there is a nice relationship between the business side, providing business intelligence, and data mining, which is more the task of working with data. And the way I see this chart is that when you do business, when you do any activity, whether you're doing maintaining your machines or hiring people and paying them salaries, or you're treating people and gathering data, okay, role of MOOCs, etc. Okay, very good. I'm so delighted, first of all you have joined, and I'm finding so many questions that I want to answer them, but I at the same time want to flow at least at the level of a larger pattern. So I'm trying to show this is a pattern, and I'll talk about patterns in a moment, because to me data science is all about patterns. You don't want too many details, because then it becomes data. So anyway, when you do business or any activity, it generates data. It can be recorded, right? I mean, how many people are logged in and what time you logged in, the questions that you asked, that's all data. When the email reached out to you, so this is generating a lot of data. You got up, you came to work, then you lay back, and your phone, every moment on your phone is recorded. Where you are, potentially it could be recorded. All that is data. The point is, what do you do with the data? So that's when you're here at business, and then you do data, and then you mine the data, which means you look for patterns, and that hopefully generates some intelligence. I say hopefully because the data will tell what it will tell. If it doesn't have much thing, then you can't manufacture it. If you manufacture it, that will not be valid intelligence. But intelligence means insights, and once you have insights, then you feed it back to data. So there's a cycle, and that makes the business grow, and you generate more data. When you mine more and you have more intelligence, you feed the business more. So it keeps on growing, and then so that's how data grows, and data becomes like big data, and you have all kinds of data being collected. So that makes it big data. The question becomes, what is needed for business the data to be recorded? You need good infrastructure, like somebody says, networks. Yeah, you need everything to record it and store it. And that's where Hadoop big data tools can come in when your scale grows in terms of the size of data. Then mining the data requires certain skill, techniques, very much computer science kind of techniques, artificial intelligence, neural networks, differential equations. You could statistics. You could use various tools. So you need some technical skill to do this one at the bottom. But then from mining to intelligence is your skill, and at what angle you dive into the data, and then you dig out. Sometimes you just work with data for as long as you need to get them intelligence. But then there's also a crucial link from intelligence to business. Do you think it's automatic that business insights from data will be used in business? I don't think so. It requires a lot of courage on part of the business executive to trust that insight and use that data. It has to make sense to them. They could be risking the business on new intelligence. So it requires courage. So the intelligence to business, you need courage, whereas in data mining, you need a lot of logical techniques. So for intelligence to be used by business, there is a need for what we call data visualization. How do you make the data visible or presented? How do you present the data in a way that addresses the problem in a simple enough way, in a general enough way, that somebody says, aha, it makes sense. Now, yeah, I'm willing to change my business a little bit, and I know it will not be too risky. So so the visualization, again, is a big part of what we do in data science. Okay. Is it applicable to technical? So it's applicable across analytics. If you're generating data, if you're using websites, if you're using social media, it is applicable everywhere. How do you start learning data analytics, etc.? You can start, and somebody asks on MOOCs, you can start with MOOCs. MOOCs is massively online, available courses from various universities. They are available from various companies. You can start courses from there, and they are relatively inexpensive, and you can start learning there. They're free. Or you can read good books and that are easy and not complicated. In particular, my book is written without much math in it, and all the programming is pushed to the back end, so that it appeals to any student or any faculty who otherwise might feel, oh my God, there's so much technology I need to understand for that. So certainly there are the books from me. It's called Data Analytics, which is with McGraw-Hill. There's another book coming out soon called Big Data, which will be more about the tools, Hadoop, Spark, MapReduce, NoSQL databases, etc., etc. The name of my book is Data Analytics. Sorry if I may. Analytics, if I can. Yeah. So this is the name of the book that I have, which is available on Flipkart. Should I? But that, I don't want to get into this thing. So let's stay with the topic and begin to work with the charts I have. But you have wonderful, wonderful questions, and I would love to address them all at one go. But let's see, what are all the questions? Which one is more important, Python or R? Data science in HRM. What tools? So there are many tools. There's questions jumping into sort of what do I start? Where do I start, right? R is a great language, and I have an R tutorial at the back of my book, and you can use that. R is a good language. Python is popular because it's useful in data analytics as well as in other fields. SAP, SPSS. SPSS Modeler is a tool that I've used extensively for many years. It's great to do. It's a graphical tool. Weka, W-E-K-A. Weka is another tool which is open source. R is open source. Python is open source. SPSS is not. Some amount of analytics you can do even on Excel, like regression and correlation and some other modeling you can do there. Is there opportunity to finance people in this field? Everywhere. The nature of the data, the domain of data, is what specifies what kind of skills are needed to work with this. What after R? Well, learn more tools, I would say. As I said, there's so many tools there, and I just described earlier how data analytics can work in HR and HRM. So let me, best online courses were, anyway, there are a lot of courses out there. You search in Coursera, data science, you will get some courses. The one from Stanford is a very good one. It's been there for many years. Okay, so let me go to the next chart, having described this thing. Where is this? Okay, Art and science of managing data for business use. Data science is an interdisciplinary field about processes and systems to extract knowledge or insights from data in various forms, either structured or unstructured. This is Wikipedia, Wikipedia's thing. So, which is what I was saying. It's extracting patterns, or insights, or intelligence. That is what data science is. Now, data is the new natural resource. That's where the scale of data is increasing. The source of data is widening. We have, just making sure that I'm not missing out any major questions. Yeah. So, can you use data science? Yes, you can. If you can work with data, if you love data, if you have access to data, and you love finding patterns in data, which I guess everybody does, or else you wouldn't. That's why you've taken the time to be here. Then you would love data science, data analytics. Everybody can do it. Everybody can do it. There are user tools available that doesn't require programming also. But data is the new natural resource. It is doubling every 12 to 18 months. It's kind of scary, the amount of data that is there. We don't talk about gigabytes or terabytes anymore. Petabytes have been left behind. Exabytes is there. Exabytes is million gigabytes. So the amount of data is growing so much, and organizations have choices. Either you sort of, I'm not going to work with all this social media data, I'm not going to work with all this web data, but then you might be left behind by competition. On the other hand, you can say, well, let's see what this data shows. Let's see what are people telling me about my business. Every Monday I see a great surge of activity about my coffee, or about my dresses that I sell, or about my company. And by the time Friday comes, everybody's talking not so good things about my company or my products or my work environment. What's going on here? So some you could say, well, it's just a pattern of the week, and you can understand. But somewhere you might say, well, something happens on a certain time which leads to good or positive or negative feedback. So you can see patterns over time, or you can see tweets coming from certain people are very positive, or what's a net positive score. You can draw a word cloud. What are people saying from that data? So you can do very many things with data. But data is there, and data includes everything. Everything is not just numbers. And I'll talk to you about various types of data in a moment. But data doesn't just mean numbers anymore. It means whole URL, and what time somebody got onto your website, etc. Internet of Things, I was just referring to IoT in some ways, where things talk to each other, machines talk to each other, machine-to-machine communication is there. They are sending messages to each other. Let's say RFID tag is pinging its status or its location to a reader and stuff like that. So all of those things are the source of data, and you can potentially find big insights and then use it as a competitive tool. Let's see. And so the important thing is that understand data, not only saying, hey, I've got to collect data, but then see logically where it goes, how it is going to be used. So that's why I was showing you the BIDM cycle, that business leads to data, data should be mined, mining should lead to intelligence, relevant patterns, which should be fed back to business, and then that makes the thing grow. And that's where this cycle has been going on for many years, and data has been growing. And what is big data? People ask, what is big data? Big data is a generic handle, a name, umbrella term used for data sets that are so large that they cannot be managed by tools at hand. So not by relational databases, not by traditional single machine data servers, etc. Requires a slightly different set of tools to learn them. Okay, let's see, somebody was writing some. How can you use data science in OM and HRM? Yes, you can. Somebody wrote again, 4 or 5 chats. How can you go about start learning in 1 or 2 months at hand? Yeah, I just talked about you can start with MOOCs. What are the advantages of pursuing if you're a graduate in physics? there are a lot of jobs in this area. A lot of it's a practical set of insights kind of tool where you can use your understanding of physics and modeling to create new models and new insights. What are the tools? Marketing analytics applications. You have, as I said, generic tools like R and Vecca, but you also have SPSS Modeler, etc. And Vecca. And what are people saying? Can data science throw light on important issues like demonetization, liquor prohibition, and various parameters? But yes, they can. We have only opinions, not facts. And to get Manish Gupta, very good question. Yes, it can. Definitely, that is where it becomes very fun. Those are the important questions. Was it successful or not successful? How do you even model it? I would love to work with somebody on how to model it. There are all kinds of data available on demonetization, and how do we judge whether it was successful or not? Otherwise, it's just one person's opinion versus another person's opinion. And if I were to just guess here, monetize and demonetize, what is the dependent variable? What are we trying to project? Let's say we are trying to project black money in the economy. We are projecting the growth rate, economic growth rate in the economy. And we can say pre and post, what's happening. So we can have many parameters of data that when you correct pre or post and see if those have gone up or gone down. And we can have a composite measure. That would be a fairly simple way of creating a metric for whether demonetization was successful or not. Now the question will come on, how do you get good data? How do you get good data on black money before and after? How do you get good data on employment before and after? How do you get good, I've heard reports that some markets were shut down during demonetization because there was no cash for them to pay their workers. On the other hand, I've heard from people that everything was going fine. I hear about urban versus rural divide, etc. So that in the cities there was problem of getting cash from ATMs, but in the rural areas there was no problem. And some might say otherwise. So if we can get good data to address that stuff, then we can answer. Now, that's where we have to manage for quality of data also. So all data we get will not be of the same quality, and we have to find proxy measures that are good enough to really prove those things. So how we model, what is the dependent variable, what is the input data available, how much it's available, or what quality is it, and we try to model it, and we'll see what kind of insights the data gives. And it's very interesting. Sometimes data gives us fantastic insights, something different than what we expected. So there are a lot of applications, and if you just take a look at my book, I've given applications for practically every industry, like fraud detection in insurance or in various other things. Okay, so let me move on. So there is a target case study. I'll move on from there. Pattern recognition. So that is, to me, dear, and really understanding what this data is all about. We can talk about tools, learning, this and that, definitely. But what is it that we're getting in the end? As I said, we're getting intelligence. What is intelligence? Intelligence is some kind of pattern. This is happening over and over again. There's an exception pattern or there is a regular pattern. Exception pattern is things are going like this, except at one moment it just drops and goes up. So if the system can feed us that pattern, okay, when does it go down and when can we take corrective action? So something is exception from the pattern or this is a regular pattern. So that's the important thing. So what is a pattern? A pattern is something that something helps you grasp something, and especially in simple and easy enough so that you can understand it. Because it's not that we are starting as a clean slate in our head. We know a lot. We know a lot. Every time we hear something new, we evaluate whether this pattern works well with what we already know or it doesn't. So a good pattern should be simple, easy, but this is a good model. If you like to use, I call the GAS model. A good pattern is general, accurate, and simple, like E equals MC squared. It's general, that it applies everywhere. It's accurate, that accurately predicts what it's trying to predict. And it's simple enough, it's short enough that in mathematicians sometimes look at as a 1-inch formula or 10-inch equation, 3-inch equation, because sometimes equations get very long. And you know what, the longer the equation, the formula gets, harder it is to explain to a business executive who wants to know, hey, if I do this, will I get this back or not? Like the demonetization example. Hey, I demonetize the 2,000 and 5,000 rupees note. Will I get rid of at least 10% of black money? Yes or no? We want to know those kind of answers with some confidence. So a good pattern would be general, accurate, and simple. So good data, bad data. Of course, bad data is something that's made up. Fake, you heard of fake news these days a lot in elections they're using. So you can make up data, and that's what a bad data is. But also, technically bad data would be just something that's got a lot of missing values, a lot of wrong values, a lot of duplicate records. That would be bad data because you'll have to clean up. Cleaning up the data requires some expertise in terms of cleaning up for all kinds of difficulties. Let's see, there's a lot of questions. Very good. I'm so appreciate that. At some point, I'll read them all and be able to answer them all. But at this point, let me move on. So the idea of all of data science is to identify patterns. And what kind of patterns are there? So I think I have some examples here in the next slide to share with you. Let's see, the next chart is coming. Okay, what happened? Oh, hold on. Hello? Chandru? I don't know, my machine died or something. Not machine died. Okay. Can you hear me?
Yeah, I can hear you.
Okay. Can you guys see me? Machine seems to be frozen right now.
Okay.
My machine might be frozen. Okay, let's see. Is my laptop working? Or can you hear me on my laptop? Can I reboot the machine? Or will it delay the thing? Chandru?
Sir, your voice is audible.
Huh? Voice is audible?
Your phone on
Even on the laptop?
Yes.
Okay. So maybe I'll just talk about these things, and even if you can't see me, right, and I can't hear you. Anyway, what I was saying was that this, and I can't, somehow my machine is frozen, and wow. Alrighty, shockwave flash is not working. Can you just pause this and ask people to hold while I restart it?
Yes, sir, I'll send out the message so you can restart it.
Huh? You can restart it? Can you ask people to stay on hold? Okay.
Yes.
Yeah, please. I want to start. It might take a few minutes, but. Yeah. So, as I was saying, what are the kind of patterns, right? The patterns are of, patterns by time, patterns by space, patterns by function. So all these functional patterns we're talking about, structure of software, a structure of hiring, structure of people, being productive at work, a structure of how medical procedures work, etc. So thank you for staying with us and continuing to listen. Okay, and so you have patterns of different kinds, and what is an interesting pattern? As I said, pattern is something that throws light on anything of interest to us, and so you can get patterns from our own personal experience, right? Or you can get pattern from data. That data helps you dig up for patterns. Okay, so let's move on. So this is the way to look at the entire data processing chain or data processing life cycle, and to understand where you can fit in terms of what you want to do in data science. So starting with data, understanding data, capturing data. Then you have databases to model data. Database is very well understood field, right? Relational database, etc. But then you have data warehousing. Data warehousing is the way to organize, maybe denormalize the data set to help with answering some questions, answering specific requests. And then this field of data mining. Data mining is the art of mining data to generate patterns. And then this field of data visualization, which means you actually present it in a graphical manner, non-text pattern, so that people can actually understand it nicely. So what is data? Now, we all know data, and you're all very experts, but I wanted to just share my sense of what data is, how I view data. Everything that's recorded is data. Data means something foundation, it's fact, it's recorded, it's in a way that can be retrieved. Although it may not be retrieved, like what is in my head is also data. Everybody hearing, chatting, talking is also data. Now, but we can mostly work with data, but that's more objectively available. But as I said, everything that you heard is data, which is inside. The good or the bad is that it is growing exponentially. As I said, it's doubling every 12 to 18 months. And there are so many more sources of data than there used to be earlier. For example, the stories, all the stories you hear, all the movies, is that data? I think it is data. You can mine those stories for various patterns. Operations, all the activities you do, that is data. Somebody's talking about time series modeling using Walmart data. You can get data about operations from a company like that, but you can also look at social media data. What are people saying about various products? People have listening platforms to track what are people saying on Twitter or Facebook about their product. So all of those are data. Machines, somebody talked about IoT earlier. Internet of Things. Internet of Things is what I call machine-to-machine communication, where machines talk to each other, and those are the larger sets of data because just the quantities are huge, especially RFID data or web data or machine maintenance data or refrigerators talking to fulfillment devices. So machines tell each other a lot of their own health check. I'm alive, and they ping various things. So that is also data. Now there are many types of data, as we know. Numeric data is where we can apply a lot of math, but then there's also alphanumeric data, names, etc. And what can you do with names? What about doing logical flags like yes, no, true, false, yes, yes, yes? So what are, these are all kinds of data. So I put them in like 4 or 5 different kinds of data, and these are well-known categories. Nominal data. Nominal data is nom is name, so it's like names. Red, green, blue, Anil, Sudipta, Harikaran, Manish, all these are Ramandeep. These are all names, and you can only count how many Kaurs are there, how many Maheshwaris are there, how many Gulatis are there in a group. That's all you can do, and then you can classify them. How many Punjabis are there, how many Sindhis are there, how many Marwadis are there. That's all you can count, and then you can compare those counts, etc. But that's all you can do. How many red buckets are there? How many green buckets are there? But then there's the next level of data is ordinal. Ordinal is order. So this data in which you can see this is big, this is small, this is super small. That doesn't mean the difference between big and small is the same as the difference between small and super small. But nonetheless, there is some sense of order. you can see that there's an order, and you can have some patterns based on that. Then you can have interval data, where you not only have order, but you also say that the difference between 1 and 2 is the same as the difference between 2 and 3. Let's say if you're doing pain, pain on 10-point scale, or I like this webcast on a 1 to 10-point scale, or I like my class by this professor on a 1 to 5-point scale. So that we assume that 1 to 2 is the same distance as 2 to 3. So we create some kind of order. Or temperature, for example. What is temperature? You take the boiling point of water, call it 100. You take the freezing point of water, call it 0, and then in between you make 100 equal intervals, and that it's an interval data. That temperature, we call it ratio data because we think it's so accurate that you can actually make a 2.37 degree difference, which means you treat it like a ratio data. And that leads us to what is ratio data. Ratio data is where there are a whole bunch of numbers, and you can have any qualitative number to do any kind of operation on them, add, subtract, square root, etc., etc. But then the bigger part is this unstructured data, text data, video data, audio data, images, graphs, and that's the kind of data that you want to work with and see what to do with. At the very least, images, etc., you have to store, right, and see what are tag them, and then be able to search them. That's kind of data mining too. And then you have data about data, the metadata of defining what is stored and the structure of each data, what is storing for every image, what is storing for every tweet, and so on and so forth. And then public data versus private data. What is private data? Something that it's under your possession, you create, and it's about you or about whatever you observe. But then what is public data? Public data is what the government makes available. And then what is this data that Facebook collects from various people, like such as all of us? We have data which we post on there, and then that's all somewhere in between. It's not totally public in the sense public doesn't know, but a lot of people are reading it, so it's not totally private either. And who owns that data? Those kind of questions also kick in with data. Okay, so let's move on. And so data mining, as I said, data science is art and science of producing insights, and data mining is kind of the same thing to me. Art and science of discovering useful and novel patterns. It should be useful and novel. Novel means new, useful means obviously it should be useful. And I'm sure we can provide this PowerPoint to people. I'm just seeing some question. My question, Facebook profiling. Well, I'll address some of these questions as they come about, and what language, how much language of programming you need, etc. will depend upon what you want to do with data mining. All languages, all tools, for example, R. Let me just jump to tools, since there are a lot of specific questions of programming, etc., and what I do with it and how do I do various things. Let's see if okay. So R has about, last I checked, there were 600 libraries, 120,000 functions, user-defined functions. It's an open source tool which continues to grow with contributions from smart programmers who want to add more facilities. Doesn't mean that number of techniques have grown a lot, but the implementation or new algorithms have come about which allow you to do things a little bit better. So that's the advantage of open source tools like R, and that's one tool. Python certainly is another tool, and I'm developing another sort of tutorial for this book for Python also. Hopefully in the next version we'll have Python tutorial also. The book that I think is that these people have shared the link with you. If you have that, there's a 30-page tutorial at the end of the book to solve all of this things with R. But as I said, Python is popular. Octave is another possible, not very popular language, but certainly is available. How can you apply data science in networking or with these tools, or somebody said Facebook profiling? There are all, how you model it, that's important thing. But if you go back to this chart, there are two kinds of learning techniques you can do. no matter what data. It's supervised learning or unsupervised learning. Supervised learning means I know what the right answer is a priori. So I have a lot of test data experience. I say, hey, learn from this and apply to the next data set. Supervised learning. So when I'm decision making, let's say how to, I can tell from all lists of things this was a fraudulent application or non-fraudulent application. This is a fraud loan or non-fraud loan. And then if I develop some measures based on previous predicting variables, a nice pattern which predicts whether this loan is going to be not successful or this particular web access is actually malicious, then I have a way of generating a learning model. So I can have decision making model which tells me, okay, this is likely to work or not, or I can predictive patterns ahead of what's going to be sales next month, how much traffic I'm likely to generate for this one, how much traffic my movie is going to generate, and so on and so forth. Then there's other kind of patterns where there is no right answer. There is no perfect right answer. For example, there is how does Netflix predict for you what movie are you going to watch next? How does Amazon tell you what book are you or what particular thing are you going to buy next? It's not perfect science. They have certain patterns with which they say those who bought this also bought this. Collaborative filtering techniques are there. Association rule mining techniques are there. So how you see various things aligning with each other. At core, I would say all data analytics is about how data hangs together or is separate. Data is all together, right? It may be gazillion pieces or it may be 1,000 pieces, a small number. But what is hanging together and what's hanging separate? That's what data mining is. Okay? And data science is being able to work with large amount of data with tools which I can put in my head alone because I can't work with the billion pieces of data. So we need to have tools, but at the end of it, we are still trying to hunt for what hangs together and what hangs separately. So an exploratory pattern, for example, clustering, this is the idea of what things hang together. These are all the professors who hang together. These are all the doctors who hang together. These are all the fashionistas who hang together. These are all the politicians who hang together. These are all the people who love new technology products who hang together. I'll market to each one of them differently, various things at different prices. Association rules is what sells together, what is bought together, what is done together, so on and so forth. I will end in 60 minutes, so we'll end wherever we can. The idea is to answer your questions as they come. This is the standard data mining process, which is a 6-step process, and let me just skip that. You can always look at it later, but let me address in a few minutes just some data mining methods and goals. Based on the kind of nature of answer you're looking at, you can have different techniques. I focus on these 5 techniques, but there are many more techniques. But essentially, they're still doing this 2 kind of learning: supervised learning and unsupervised learning. So decision trees are a popular, easy to use machine learning technique for taking large amount of data and distilling down to a small, simple set of rules that allow you to make decisions. Regression analysis is a statistical tool which allows you to project some data patterns into the future. You use regress, you go backwards in data, look at the back data, and then draw the line forward, see what kind of patterns could be there. It doesn't have to be a straight line, it can be a curved line, it can be an exponential line, but some kind of smooth curve that will fit the data. Artificial neural networks are the rage today. It's also called by neural network. It's also called artificial intelligence. Various techniques are there, and some people have called this getting so smart, very sophisticated, not sophisticated, versatile machine learning techniques that can be used for supervised learning and unsupervised learning techniques. Using neural networks is not very difficult, but designing neural networks would be a challenge because they require a lot of differential equations, a lot of high calculus and math to understand those. But very, very powerful deep learning. Google is doing deep learning. It's all training the neural networks to, for example, recognize faces on Facebook. That's done through neural networks. It's an unsupervised learning technique, but you make it better over time. Clustering is an unsupervised learning technique, which is you look for similarities within various data sets. and association rules are X leads to Y, or X and Y hang together 80% of the time. So I have good confidence that if you bought X, you will likely to buy Y also, which has implications in terms of I can bundle the products together because these things are hanging together, or I can put those products separately in different parts of the store. So you come in here and then you walk all the way to the store and end up buying a lot of other stuff as you reach the other item in the store. FP profiling. Some of you can answer each of those questions, I'm sure. So go ahead, answer. Let me see if there's then there's important thing with data visualizing. This is very important for those who think that it's all about technology and all about equations and all about math and statistics. There is this beautiful area called data visualization, which is how you present the data, what kind of graphs, what kind of curves, what kind of dials. That's how do you make those graphs? How do you present that data? That's very, very important. You have, it's like a dish you have, but you can't eat it. What's the point? You have to serve it in a way that somebody can eat it. Now let me go to this, because I love this eating metaphor a lot. Maybe I eat a lot and gain a lot of weight. But the difference between data mining and big data mining is what? If data mining is working with small amounts of data, Tableau is one set of tools that you use, and you can use R and others to do the visualization. But if you get cooking for 2 people versus cooking for 200 people, or let's say cooking for a gathering of 10 people and cooking for a wedding party of 1,000 people, is there a difference? You might be cooking the same stuff, same dal chawal, same roti sabzi, same mithai, but if you're cooking for 2 people, it's easy. You can do with love, you sort of have a lot of fineness, etc. But when you're doing for 2,000 people, it requires different scale of materials, a different scale of the recipes. You have different even burners and stoves. So that's the difference between data mining and big data mining. Big data provides the vehicles, the vessels to handle large amounts of data and to move a large amount of data at very large speed. So Hadoop is a new way of storing. Now Hadoop 2 has come and various other tools, Spark has come on, but storing large amounts of data in a way that doesn't rely on a very huge machine. There is no large machine that can handle all the data in the world. Facebook has a data center with millions of servers that collectively store all the data that we generate. Images and audios and videos and text, everything. It can never be stored in a single machine. So that is the idea of distributed storage, partition storage, using very cheap machines so that it can still be stored and still be available. Because of the cheap machines, you have to replicate everything in 3 different places, and you need software that makes sure everything is replicated, and I get the data from at least one replica. So the quality of the data is testable, and I can use that good data. So big data, the tools like Hadoop, Spark, MapReduce. MapReduce is a particular kind of a programming, parallel processing algorithm where you can break down a problem into 2 parts, map it out first level, get some intermediate results, and then reduce the intermediate results to the final output. For example, how do you do search? How does Google do search? You put in a set of terms, let's say, how to learn data science. Now this is 4 words. Let's say cut out how to learn data science. You've got 3 words. You can search with learn, you can search with data, you can learn with science. Each one will give you 1 million hits, 10 million hits, or 2 million hits. So those are intermediate inputs, and then you take the intermediate search inputs, outputs from those 3 searches, and then organize them, and then prioritize them, and present the first 10 or 20 links to you on a Google search page. All of that is done in milliseconds and a fraction of a second. So you don't notice, but that's billions of nanoseconds. So there's a lot of time for the computer to search like that. And all those tools are indexed at some level, so you can search them quickly. So MapReduce is that kind of tool. Spark is a tool for data processing, so that a lot of the processing can be done in memory using some in-memory construct. So you don't read and write into the hard disk a lot of time because the speed is of the sense. Then there's so many other tools in big data, which I talk about in big data. NoSQL databases. NoSQL means SQL doesn't strictly apply to them. Strict SQL doesn't apply to them. You want to be able to search them, but they are not necessarily completely relational tools. So those are some of the tools we have in handling large data set: MongoDB, HBase, and Neo4j, this graphic database tools, and other databases are available for that. Can it be used for, yeah, PageRank algorithm? I have PageRank algorithm as a social network analytics is another set of techniques to look at networks. Somebody is asking, can it use for networking? Yes, you can take up the data, and if you look at the graph as a set of directional links as going from one place to another, right, a directed link, then you can see where's all the influence going, and that's PageRank algorithm, which helps. Can a person without programming knowledge to work in data science? Exactly. See, this is where we brought up data visualizing. It requires a lot more creative output, a lot of conversation with the user, bridging the user's need and the data, what it's saying, and then use some of the tools to present the data in compelling manners. So there are many tools available. Tableau is a very popular tool, the #1 tool sort of by far. But as I said, there are a lot of open source tools available, a lot of graphical tools available which will produce graphical outputs such as your decision trees and regression equation and various other things. Let me see if I have another chart here. Maybe I'll just stop here. So, and there's an example here. So let me take last minute to cover an example how we can take the data. So let's say this is your transaction data of sales of a product. Which date sold, what product, which location, what is the value of the sale, how do you make sense out of it, how do you get insights out of it. So let's say you create from this database of things, what you create is what we call a data warehouse, in which you roll up all the sales by quarter, by product. We remove the geography, location, just not by month this time, but by quarter. In quarter means quarter, 2 means, April, May, June, like that. And so we total up the results like this. So this at least gives you a small database, and we can look for some patterns in this. And if you look at patterns in this, you can do simple cross tabulation by quarters on one side and products on this side, and you can see which is your top selling product, which is a top selling quarter, and then you look for some insights, and you find that one of the products, Matrix, it's a seasonal movie. It sells only during quarter 3, right? High sales, but only during one season. That has insights for you in terms of when to stock it, and when to stock and have maybe your more traffic will be coming at that time, so you staff up your operation to handle the larger traffic. How to work on real live streaming data for data analytics? Exactly. Use tools like Spark or front end ingest software like Kafka to get all the data in. But again, the techniques you will apply will be very similar. You will count them, you will store them, and then you will apply some of these data analytic techniques to give this output. You can use, people have mentioned various tools here: Kafka, Storm, Spark, Scala, MapReduce. Hadoop and MapReduce are older tools that were invented with a different name by Google long time ago. So that's what it is, and I think this is, let me see if there's another chart here. Thank you. Data cube is more like, the data warehousing was more like a data cube. Anyways, so nice to have talked with you, and let me see if there's any other question that comes to mind that I have not answered. Thank you, Abhishek. Thank you. Appreciate everybody joining, and let's see. My email ID, I can share I'll share my email ID if you want to write to me. That's fine. I'm okay with that. And I think these people will, McGraw-Hill people have shared with you my book link, so you can take a look at the book. It's a very easy book, very easy read. Like it or not, my father was able to read it, and he's long retired, and he could read it and he could understand it. So he's not a technical person. So it's written about technology, but written in a way it's not difficult. It's out of stock? I don't believe that. Is it out of stock? I'll check with the Amazon people if it's out of stock. How can it be? Okay. Thank you for letting me know, because I'm going to tell them this is, they should print many more copies of it. Okay, so please, I'll ask them to share PowerPoint, and my email is there. I really appreciate your joining. Thank you very much. Have a great evening, and we'll talk to you again soon, hopefully. I send my email ID. Okay, appreciate. I could not answer everybody's question, but I guess answered quite a few, and we can answer more as we go along. It's good for students. So yeah, if you have any questions, I'll be glad to answer. It might be taking some time, because with other things happening, but I would be delighted to hear from you how it goes. Thank you very much. Okay, McGraw-Hill people.